Student, yesterday we have discussed about the last time on Saturday about the balanced and unbalanced force. What are the balanced force and what the unbalanced force? The summary of that day is it necessary for an object to be in the motion? Is it necessary for an object to be in the motion however multiple forces are being acted on the I'll explain this. Multiple forces are acting on a body. Is it necessary that the body will be in the motion? No, it's not necessary. The motion word is not very perfect in saying that multiple forces. We can say if many forces at the same time acting on a body, is it necessary that the body will change its motion to rest to motion, direction, shape? No sir, it's not necessary to change. Why? An example, a student in class start to pushing the ball. Will the wall move ahead? Obviously no. Because the answer replied by you, sir, it's a massive, big mass is there. So right guess you have. Its mass is actually its measure of inertia. The word inertia we have explained that. Clear? So its mass is the measure of inertia. More the mass, more the inertia. I'm explaining this. If highly massive body, you want to make the motion. Highly massive body, you want to make motion. You want to make the rest. You want to set the body in rest. You want to change the direction of the body. You want to change the shape of the body. Is it necessary that the body will do so? Obviously no. The body will not do so. It is not necessary. Why? It depends on the magnitude of the force which you are applying on the object. In case of the wall pushing, one is pushing the wall and even the ball is not getting motion. Why? Because the mass of the wall is very much. This is the high inertia. So it's not sufficient to speak that the force is applied on an object or a force when acts on an object, body starts moving. No, it's not necessary still, right? No? The concept of balancing and unbalancing force now arises here. Many forces together, many forces are acting on a body and body is still not changing its inertia. Body is still not changing its motion, direction, speed, velocity, that is, shape. Then the body is said to be in balanced situation. The body is said to be balanced and the force at this time acting on a body is called a balanced force. This is called balanced force. And what the unbalanced force? The force is said to be unbalanced. So just converse. If force acts on a body and body just changes direction, speed, velocity, comes in motion from the rest and set into the rest from the motion. Now sir, the force is to be unbalanced. One thing also we have discussed yesterday. Any object moves, whatever the force you applied on it and whatever the force were applied on the object, a body changes inertia. So the inertia changer force is the force applied by you, means the equal amount, the body by which the body is moving. The force by which the body is moving, the same force is what you applied? No. The sum force ever goes in overcoming the situation. The word overcoming the situation means first your force try to wake up the body. Just get up body, you need to move. Move now, start, get up, change your direction. This is the force. Means some part of the force always just goes in overcoming the situation. Clear? So the concept of applied force is not sufficient to speak. Net force the word comes here. Okay? So what do you understand by the net force? The vector sum of all the forces acting on a body, vector sum. Like I'm giving back net force concept. Suppose there is some example we are giving. There is a block of mass m. Here, it's mass m, and it's tied with a string. You are applying force here. Clear? A boy is pulling this in this manner. Is that clear? So the force has been, however, resolved in the two components. One part of the force acting here, this is called parallel component, and one force acting here, that is perpendicular component. Clear? Not? I mean, this force is divided in two parts. So you may see that this force is trying to set the body to rightward. This F parallel is bringing the body right. Clear? Obviously, another force is also working here. This force is called what? Friction force. Everybody know this. The friction always opposes your motion. Clear? So first your force, suppose F parallel. Your F parallel is, suppose it's 10 Newton. Your F parallel, suppose 10 Newton. And your friction force is, suppose 2 Newton. So by what force? By which force? By what amount of the force the body will move? So body will move with 10 minus 2 is equal to 8 Newton. So what is 10? It's called applied force. What is this? It's called opposing force. So we can speak here force 1 plus force 2 is equal to, this is called net force. The word we are saying the vector sum, because their direction is in this manner. Their direction is this. Clear? So one opposing the other. So body is moving with net force. The concept of net force well understood. Clear? So yesterday this thing we have discussed about the balancing and unbalancing force. Right? So is it necessary that a body is in the motion, continues in the motion, and the balance force is acting on? Yes, sir. Balance force is not changing its motion. You are sitting on the chair. What type of force is working on your body? Balancing or unbalancing? Balancing. You just fell from the chair after breaking the chair. After gets broken the chair. What? Yes, sir, unbalanced. The force became unbalanced. Right now? Well understood? So each body which is continuous motion, continuous direction, continuous speed, velocity, continuous shape, all are acting or experiencing balance force. We can speak here. So we need to change their inertia. We need to change their direction. We need to change their velocity, speed. So a force is required. This is giving the clue toward the first law of Newton, the first law of motion, as Sir Isaac Newton gave the ideas and the basic concept in motion, what happens when a body moves. Okay, this set of rules are called the Newton's laws of motion. So I am telling the Newton's laws of motion. Newton's laws of motion. We will discuss the Newton's laws of three motions. We will discuss here. Clear? First is called law of inertia. Second, we will discuss about the law of momentum, and third, we will discuss about the law of reaction. Clear? Reaction. So we have already discussed the law of inertia. We have discussed this. Okay. What is called the inertia? The property of body. By virtue of that, a body always tries to oppose its motion, its direction. First, you need to understand the inertia. Rest, motion, rest, motion, and what next is direction, velocity, or speed, and direction, or what next is shape. Yes, these are the inertia. Inertia of rest, inertia of motion, inertia of velocity, inertia of direction, inertia of shape. These all, if go on change, means force is required, force is needed. Clear? This is law of inertia. Not only this in the case of force, but in the practically this also happens right now. Sometimes a student does not do work their own, okay, until the force is applied. Parent when apply the force on the student, then they start working. They just don't want to break their inertia. They just don't want to study. No study, continue their inertia. So when the student will break their inertia of study, not studying, inertia of not studying inertia it is called. When unless an external force is applied. When unless an external force is applied, The student bags is in a sphere, right now. So not only in the science, this also happens in practical life. The body will not continue. The body will continue its happening, whatever is in the position, unless an external force is applied. So force is very important in, we can say, application of the practical life. Not only in the science, physics also, in practical life this also works. Is that clear? Please come on to that. And now we are discussing momentum. What do you understand by the term? Momentum. So before discussing the law of momentum, we need to discuss here momentum. Our concept is linear momentum. Linear momentum. The word linear momentum we are saying because it's another momentum is also when a body moves on a circular path, then its momentum is said to be angular momentum. When a body moves along a straight line, then the momentum of the body is said to be linear momentum. Linear but straight line motion. Clear? So what is linear momentum? We will just perform an activity in the simple way. Is that clear? How this happens? An activity will perform here about the momentum. Lighter body makes, heavier body makes. Okay? An activity that will help you to understand. Please write this about the momentum. Okay? I am giving the definition, then make an illustration. Is that clear, guys? Please write this. The product of, go on writing, the product of the mass and the velocity, the product of the mass and the velocity, product of mass and the velocity, product of the mass and velocity, product of mass and velocity is called linear momentum. This is numerically linear momentum. Clear? It's not necessary always. This is called linear momentum. Okay? So we'll perform an activity here simply. Have you seen a heavier body? Suppose that an activity will perform here. A massive thing when thrown. Yes? Ball. Like you take a small stone, you take a big stone on your hands right now, and if you will throw this on the glass, and you will take a small bullet that's fired from a gun, it also thrown with the same effort to the glass, you will make the different impact over both situation here right now. So we'll perform an activity here, see on the screen, that will help you to understand. That later I will speak, give you the information. Clear? However, combined effect of mass and velocity is there. Is that clear? Right, guys? Now just see that. See on the screen.
Objectives: to understand Newton's second law of motion, and to understand momentum with examples. We have already seen in the Newton's first law that a body does not change its state of rest or of motion unless acted upon by an external force. In other words, we can say that the change in motion or acceleration of a body depends upon the force acting on it. But the first law does not show us how acceleration of an object depends upon the force acting on it, whereas Newton's second law gives us the relation between force and acceleration. If a slowly moving cricket ball hits a person, it would not hurt her much. But if the ball is moving at a high speed, it will hurt her severely. The difference in both the cases is the velocity of the moving body, that is the ball. Now, if the person is hit with a tennis ball, the impact is once again less than that caused by the cricket ball. The difference in this case is the difference in mass. With the help of these examples, we can define a new physical quantity called momentum. The momentum, P, of a body is defined as the product of its mass, m, and velocity, v. The SI unit of momentum is kilogram meter per second. Let us see another example to understand momentum. Take two marbles with the same mass. Hold the first marble at a height of 2 meters above the glass top of a small table. The marble has no initial velocity. Release the marble. It attains a certain final velocity and hits the tabletop with some sound, but does not break it. The other marble is held at a height of 5 meters. Its initial velocity is also 0. Now release the marble. It attains a much larger final velocity than the first marble when it reaches the tabletop. This marble hits the tabletop and breaks the glass at the point of impact. Let us now take two marbles with different masses, that is 10 grams and 100 grams. Both are released from a height of 3 meters, so that they have the same final velocity at the point of impact. Tabletop and breaks the glass at the point of impact. Let us now take two marbles with different masses, that is 10 grams and 100 grams. Both are released from a height of 3 meters, so that they have the same final velocity at the point of impact. We observe that the marble with greater mass breaks the glass top, whereas the marble with less mass does not do so. Hence we infer that an object having more mass or traveling at a higher velocity possesses greater momentum. Now, with the help of momentum, let us understand Newton's second law of motion. Newton's second law of motion states that the rate of change of momentum in a body is proportional to the unbalanced force acting on it, and takes the direction in which the force acts. Consider an object having mass, m, which is moving along a straight line. Its initial velocity is u. Now an unbalanced force, F, acts on the object which is uniformly accelerated. After time, t, its final velocity is v. The initial momentum of the body is given by p1, which equals m into u. And the final momentum of the body is p2 equals m into v. Here the change in momentum of the body in t seconds is given by p2 minus p1, which equals mv minus mu. Therefore, the change in the momentum of the body in 1 second is given by mv minus mu by t, that equals m into v minus u by t. We know that the change of momentum in 1 second is nothing but the rate of change of momentum. Hence, the rate of change of momentum equals m into v minus u by t. Equation 1. According to the equation of motion, v equals u plus at. Therefore, a equals v minus u by t, equation 2. Substituting the value of equation 2 in equation 1, we get the rate of change of momentum equals ma, equation 3. We have already seen that the rate of change of momentum is proportional to the unbalanced force. From equation 3, we can say that ma is proportional to the unbalanced force, which can be denoted by F. F is proportional to ma. This expression can also be written as F equals k into m into a, where k is the constant of proportionality. Now, assuming that a unit force acts on a body of unit mass, thus producing unit acceleration, we find the value of proportionality constant k to be equal to 1. Substituting this value of k in the above equation, we get F is equal to m into a. This is the mathematical expression for Newton's second law of motion, which gives us the relation between the force acting on an object and the resultant acceleration produced in it. That is, the force acting on any known mass can be measured by finding the acceleration produced in it. By t. Equation 1. According to the equation of motion, v equals u plus at. Therefore, A equals V minus U by T, equation 2. Substituting the value of equation 2 in equation 1, we get the rate of change of momentum equals ma, equation 3. We have already seen that the rate of change of momentum is proportional to the unbalanced force. From equation 3, we can say that ma is proportional to the unbalanced force, which can be denoted by F. F is proportional to ma. This expression can also be written as F equals K into M into A, where K is the constant of proportionality. Now, assuming that a unit force acts on a body of unit mass, thus producing unit acceleration, we find the value of proportionality constant K to be equal to 1. Substituting this value of K in the above equation, we get F is equal to M into A. This is the mathematical expression for Newton's second law of motion, which gives us the relation between the force acting on an object and the resultant acceleration produced in it. That is, the force acting on any known mass can be measured by finding the acceleration produced in it. Summary. The momentum p of a body is defined as the product of its mass m and velocity v. The SI unit of momentum is kilogram meter per second. Newton's second law of motion states that the rate of change of momentum in a body is proportional to the unbalanced force acting on it, and it takes the direction in which the force acts. And Newton's second law of motion gives us the relation between the force acting on an object and the acceleration produced in it.
So have seen this, okay? Second law, Newton's second law of motion. The combined effect of mass and velocity is called the momentum. Clear? Bullet fired from gun make a greater impact over the target, and a stone big thrown with the hands make the less impact. That also makes the greater impact. Means the mass must be greater or the velocity. It means how much the impact will be made. Both. This is depending on both. It depending on the mass and depending on the velocity. Means not only the velocity is efficient here to make the change. So we can speak here the concept of force means when the body is going just getting slower its velocity. So obviously it is transferring something else, is giving the push and pull toward that. Clear? This is called a change in momentum. So what the statement second, the change in momentum. Further we'll discuss about force, but before that, the combined effect of the mass and velocity is called the momentum, and this is a vector quantity. Numerically we can write down, this is for vector. So what is the SI unit? SI unit of that can be, SI unit is kg and its SI unit is meter per second. So the SI unit of momentum is kg meter per second. Is that clear? What do you understand? Momentum. Numerically it is equal to product and velocity. Now Newton's second law of motion. What do you understand by the Newton's second law of motion? So as we have seen here, Newton's second law of motion, force applied on an object. Suppose that a body will continue its in the motion. You have a study in the law of inertia. Body continuously moving means its momentum is constant, fixed its momentum. If you give the change to the velocity, you made the change in velocity. So obviously the acceleration now comes here. Is that clear? It means you change the velocity. This you have done with the help of the force. So we can speak here, force makes change in the momentum. So how much change will be made depends on the force. So according to Newton's second law of motion, the force is directly proportional to the rate of change of momentum. This is del P, the change in momentum, del T is the change in time. I mean, this is called time interval, where del T is called the time interval. This is called time interval, clear? And after that, we'll remove the proportional line K here. It's a del P divided by del T. And here we have solved this on the animation, clear? However, I will tell you this later. Is that clear, guys? Well understood Newton's second law of motion. F is equal to ma we have derived. Right now, your assignment of the day. Just after that, in-text exercise you have to solve. Page number, just next is page number, you may see that, page number, this has 7, 5 you will see that. In chapter number 9, the in-text question, first 3 questions you have to solve. These are based on the concept you have studied there. Thank you very much and I stay.